so much for attending. I definitely think you can already tell by now the topic is going to be too much into the blur effect, and we will try to take a bit of a closer look at the effect, and we will try to look at it from edge to edge, and they will be touching from few different angles, but the main important one is overcoming the limitations. But let's start mainly with the first item here, which is the limits. We'll be having one thing for you, for anyone who is looking, if they get bored during the talk. I have something in the slides where it's very easy to unnotice, but if you get bored, you can try to figure out at which slide am I going to stop talking. So figure that out. I'm not going to give you any more hints, but let's get started and talk about the limits. First of all, this is a very famous design, as you can see here. This is the card from Apple App Store. If you go to the App Store right now and you look up for today trending apps or wherever, you will see this design. So one interesting area about this design is the blur where we are trying to show the text here. So this is a very common effect. Sometimes when we have text that is a little bit bright and we have a background that is too dynamic and we don't have control over the background, we try to use a blur effect or a gradient or a shader mask or whatever it is, just to make sure that the text is always visible to the user. What's interesting about this one is that the blur doesn't end at some point. We don't know where it ends, it fades. And this might sound like a very easy thing to do, but let's take another look here. This is from the new iOS 17. If you go to the iOS 17, to the home page and you try to scroll when you're at the home page, you will see the blur is gradually, well, it's very hard to see here because the quality is not that good, but you will be able to see it if you go to your phone and try to scroll at the top there. The blur there is being gradient and it's fading out. It does not completely stop at one point. This is another example here, a different thing, but you could say that this is a very common theme for people who do photography. They can tell that this is a lens theme or a lens blur effect that we sometimes, if there is a background that is filled with lights, you will be able to see that light very, very easily, or you can switch the focus from one subject to the other using that filter. So the question is how easy it is to do that in Flutter. Now the answer will be to use one of these widgets. The first one will be image filtered. Image filtered is a widget where you can apply it on top of any other. So let's say we have an image, we apply the image filtered on top of it. Image filtered allowed us to access the image filter from Flutter UI, where we can do multiple. I think this is working, hopefully. Yeah. Okay, I'm not sure, I cannot hear it. So image filtered is just going to be serving as a component where whatever the effect is applied is going to be applied only on that widget and that widget only. So if we have an image and we want to blur it, we use an image filter. In our case, we weren't trying to blur the image, we were trying to blur the background, which we don't have access to in that manner. So we can either blur the text, which will stop at some bounds, or we can blur the image and try to clip it, where we will show those bounds clearly by our blurrings. The other one will be to use backdrop filter. Backdrop filter has the same access to the same Dart2A API for all types of filters, but this one gives you the possibility of applying the blur on whatever is below it. But we go back to the same problem, which is how are you going to say that the blur is going to stop here or without clipping, because whenever you apply the backdrop filter, it's going to literally blur whatever was below it, even though if it's not inside the exact tree that you're looking at. So blur effect is not going to take you anywhere. There is another option called container and box shadow. That's where box shadow has a little bit of a blur effect that you think might work here, but give it a try and you will see that it's not blurring the thing, it's just doing the surroundings around it. The last option would be to use our favorite widget, the custom painter. So custom paint, where we can draw whatever it is that is impossible in other UI frameworks. So if we want to do that, we will have to go through some paint that we will be looking at a little bit later. But here is an example around the effect again. This is a very high quality one so that you can see the difference. The blur doesn't stop, there is no clipping or anything else, it's fading straight away into the view. So now, if you want to apply any of those options before, it's always going to end up with a very nice haircut. It's a very good trim, and that's the best you can do with Flutter. It's always going to get back to this one, which is the line. There will be always a line, and we're trying to get rid of that line. So let's blur the line, and before we do that, let's take a look at some of the other examples where we have different blur effects that are probably a bit easy for some of them to remember the name, but let's start always from the left. The first one seems to be the cheapest one because it does have a bit of a quality problem, but it does the job of blurring the image. It's called the box blur. It's one of the cheapest. Second one is a radial blur with a focus point at the top. The other one is called the tilt shift. I'm pretty sure most of you have seen that effect in photography where you have a view and everything inside the view looks like it's smaller, like a Legoland or whatever. That's the effect called tilt shift, and here it's showing up at the top and at the bottom over there. We have another one called the shape blur. The next one will be, I assume, the lens blur. The other one is very mean. It's called the mean blur. We have to the right a surface blur where if you notice very, very closely, you will see that the blur is applied only at the edges. So it's trying to smoothen the edges while keeping the picture looking as good as it is. This reminds me of Snapshot filter. So it's called the surface filter. We have now here before in the middle is it's the glass from the glass morphorism effect, and the last one will be something I totally don't remember. So I'm pretty sure most of you will be able to notice the difference, but believe me, those were different. I have had so many looks at them, and they were different. Some of them are very clear that they are different, but some of them, if I compare them one to one and play a little bit with the values, it will be very hard to see the difference. So now we go back to our favorite one, which is the Flutter blur. This is what the Flutter blur looks like. It looks way more natural, way more smooth, but no way close to the others. This is only what we can get with our Flutter blur. With that, we can try to customize it a little bit and see what are the possibilities of Flutter blur. So just to make sure we are on the same page, Flutter blur always go like, is it a backdrop widget or an image filtered or a custom paint or whatever it is, it's always going to go to ui.imagefilter.blur, whatever. From there is going to be the same from here. So here you set the X and Y for the sigmas, and for some reason when you set Y to 0 is going to, or X or Y to 0 is going to disable the whole thing from working. I don't know whether that's a bug or just the current status, but the way I was able to hack around it just for this demo is to put a value near 0, but it is not 0. So here, if we play with the X, you can see that the blurring is happening only on one direction. For the Y as well, it's happening only on one direction. And they have a flag for performance reasons. If you want to disable the effect, for example, you are in an animation and you want to disable the whole effect, you want to use just the feature called enable it. It's very hard to notice because that widget doesn't have anything apart from the image filter. So instead of just doing an animation where you move the value to 0, it will be way more performant just to do it with that flag. Now I have another option in the image filter, which is the tile mode. This is not specific to the blur, but it's very good to know if we are talking about the blur effect. As I said, this also will be very hard to see the difference, so I put them next to each other. But these are the tile modes, and they are mainly about the edges, so you can see a little bit of a difference at the edges. I tried to do it with the one with the blur where we are manipulating the x-axis so that it's very easy to see. I will give you the slides later to see the difference, but what you can take from here, at least from the name, is that we have a blur. A blur takes its surroundings to decide the color of the pixel. So what if you are at the top left and there is nothing outside? So it's always going to be black? No, those are the options here. So the option mirror is going to make another image that is exactly like this, and it's going to mirror it on the other side. Same for this one. A clamp is going to literally clamp it and stop, so that when we have a clamp on, you will see a little bit of black effect to it. Repeated is going to do the image next to each other. So repeated and mirror, they might look the same, but they are not the same. They are just they are just faded into each other because of the demo here. But repeated is going to make the image multiple times and at the edges, while mirror is just going to mirror it at the edges. Decal is another option where it will be transparent, so if the effect is not going to be completely blacked out, but it will be transparent. We will see it in a better details here. So this is a better example where I'm pretty sure, without naming it, you could tell that this is the mirror, and that's the repeated, and that's the decal, and that's the clump one at the top left there. I hope I get them right. Otherwise, let's move on and see if anyone got them right. Now we have seen what is possible. Do you think that's enough, at least to get what we have seen in the first few examples or in the first few images? To understand that, let's jump to another arc and see how it works, of the whole thing, how it works. So, as I said, this is the image filter from the dark side. There is a blur effect that is somehow calling a Gaussian blur image filter. It takes only sigma x and sigma y with the tile mode. I'm just going to do a bit of investigation here, so it will be very easy, just so we can get to the bottom of it. Gaussian blur image is another class that is just referencing and holding the data to send it to somewhere else. It is still here on the Flutter side, but here we are to the point where it's using the app native annotation. So meaning from here we are going to the flutter.engine, and this is the entry point for it. It's using something called DL blur image filter display list, the new one that was updated by Flutter team in the last year. So it was a very good work that made this stuff way more performant. And there is a lot more investigation to it, but I'm going to go to the bottom where we have the code for the blur itself. So this is GLSL file where the code for the Gaussian blur is being stored, where you can see how it works or what version of the Gaussian blur is there. You can see that they have already a couple of nodes for optimization, so that there is a possibility of getting that better. They have also other ones, so it's not the only one. It's not all the blur in Flutter, even though they are always going through the same function in there. It's not always going to end up using the same one. So we have another one here called rect blur.frag, which is short for fragment shader. But here is another one called border mask blur. So here, for example, each time someone took some of the widgets take another path. So for example, here rect or rounded rectangle blur is going to be used, for example, in the case of just an image filtered or inside like a widget where it has like a very clear boundaries. Where here Gaussian blur is probably going to be used all over the other place, and something where like backdrop is being used. But it's not very straightforward like that. But all of these are the code where the blur effect is being stored by itself. And this is here all shared by the logic of the Gaussian blur, which we'll take a look in a bit. So here I want to understand how do we get from this picture to this picture, taking Flutter out of the context, taking Android, React Native, or whatever it is. I just want to understand the magic behind it. So let's take a little bit of a look at some math samples. So here, the app that just stopped, so just going to run it again quickly, hopefully. Unless, oh yeah, this is not real phone, so it will work. Hopefully everyone can see it. So we have here another sample here called, another sample app called Gaussian Blur Interactive Explainer. So as I said, we want to go from one image to the other. Images are just a set of pixels. So here, for simplification, I have a random pixels generated on this grid. So I want to go from this to a blurred version. So what we do is we click on the first item. The first item is going to have something called the kernel. The kernel is going to look at the values around in it or surrounding it, which are called the nearby values. Here we have a kernel that is 3 by 3, which is one of the most commonly used for any type of blur, but it can be something larger if you want a smoother or more noisier or whatever is the case for you. But this is just for simplification. We have the kernel here. And we have here what controls, or the sigma in our case, or what controls the blur, sharpness, and brightness as well in this very simple UI here. So if I want to apply in this case at this color here that I'm clicking, I want to apply it. So I'll double click here. So this will be the color in the new picture based on a function and taking into consideration all its surroundings. So this is what the final color will end up being. This is the same for being here, same here. I can do it for all the other pixels one by one. Why I'm doing it this way is that it means that you can do it, you don't have to do it one item by another. It's always about, it's linear, where in a way you can do it for each of them individually in a separate way. So here I will do it again. I'll just try to make it do it by itself, but this is how it's going to end up with the final result with the default one. You can see that the colors are almost being fading out, but that's just because of the sigma. So if I change the sigma again to something near 0, it will literally just replicate the image, and it will not do something interesting. It will just keep the same image. But the thing to take away from this is that we have a kernel. The kernel is going to be 3 by 3 or any other odd number by another odd number. In our case here, the numbers do not make sense yet, but it's using something called the Gaussian function. So here, all of these numbers are called weights, and they represent the color. In our case, they are. I'm just trying to show you that they add up all to 1. So here, if I get a little bit far away, these numbers, all of them in the kernel, are still all adding up to 1 because of the Gaussian nature of this function. If I go back to 0, it will be at the middle one. So if you see that curve, it's like the bell curve is just is getting even larger or just smaller whenever we get nearby 0. So that's how it works in behind the scene. So if we take all the noise out of it, that's how the Gaussian blur that is used by Flutter is working. So now we go back to the question. If we know the logic, it sounds very simple. We can literally do that with a custom painter in Flutter. So this is the macro. I'm not going to read all of it, but it will be taking a lot of operations, and it will be heavy, and your Flutter will be lagging, your app will be lagging, especially if you have high quality images, unless you do something else around them, but it will not be as smooth as doing it on the GPU. So the GPU is the graphical processing unit. Just making sure that I know that. But the CPU, which is commodity processing U-bit, is obviously something else. But when we do something on the custom painter, it's happening on the CPU. So it's happening one operation after another, as you can see in that visualization there. I'm not going to speak a lot to it because it's pretty much self-explanatory. But once we go to the GPU, we will be able to do way more operations in a parallel way. We can try to do some hacks around doing more stuff in a parallel way in the CPU, but that will be very cheap compared to just doing it in a native way using the GPU. So that's just the nature of graphics pipeline, and we will be what we have seen was changing the colors. So this is the graphics pipeline. This is what the graphical processing unit does in order to get something from just a bunch of random numbers into something that looks real to the user in the screen. But what we have seen so far is that Gaussian blur is something happening at the pixel level where we are just changing colors, and that's why we're looking literally at the fragment shaders. And this is a very simple fragment shader. This is the simplest one that you can write, and this is now possible to do with Flutter. So we can write a fragment shader in Flutter, where this shader here is just showing a color that we will be providing as a parameter or a uniform in this case. Another example here with some Flutter code of how we can show a red box in the center of the screen. That's what the next example is doing here, with showing the Flutter logo or the Flutter color in a way without using the uniform. The uniform is just sending some data about the resolution of the screen. But that's just a simple overview about fragment shaders. Now, time to overcome the limits. So to overcome the limits, we have first need to see what we are trying to do. So we have seen a couple of demos, like, or sorry, not demos, but just pictures from different types of blur, and this is just some fact about them, or at least the way I used to remember them. Like the box one is pretty much the simplest and the cheapest one. The Gaussian blur is the most popular and the most natural one, and then radial motion, and all of them have something unique about them. It's just a very easy way to remember it. So I'm just going to keep these, and you will look at the slides later if you want to. So let's take a look at the first demo, which is all of them. So we have here an example where all of those pictures that you have seen were using fragment shaders. So I have here in my code base that I will be sharing publicly just before the end of this talk here. So we have here in the shaders code, I have a shader or a fragment shader for each one of the effects. I didn't provide everything as a uniform. I have left something here for you to change if you want to adjust the values, or for example here the blur size for each one of them. The Gaussian blur here as a different implementation to the one that is provided by Flutter. The glass blur, the lens blur, the me blur, and all of them are here in a way that I'm just going to show them to you in a nice way. Books again, Gaussian, lens, mean, motion, just so you can remember that it's moving. Radial and shape, smart, surface, tilt shift, glass, and this is the Flutter one, just for comparison, in order for, like, I have put it in a nice way so that you can see the difference, because it will be very hard to tell what blur it is just by looking at it, unless you have looked at those pictures for so many hours. But right now I think it will be very easy to have them all in one place where you can tell which one is which and how to use it. So that's the first demo. I definitely don't want to show the code for each one of them, but it's always public in something called Shader Pro. That's where all the best people who create performance shaders hang around and create really nice shaders. So that was the first demo. We have seen all of them. The next one is the one I started with as a problem, which is the fade blur. But will be a question is why I showed you all of those demos before, because sometimes they look like they are unuseful, like they will not be useful until you have found the use case to them. But they are all useful. So here, if we go back to all of these blurs, which one do you think is going to be the one to help us achieve that effect? Is it going to be, this is not the view. So is it, I don't think you can see them, but if you can take another look, I'm just straight going to go to the one. So it's the tilt shift one. So the tilt shift one, it gives us the closest thing to that effect, but the only problem that it's at the top and the bottom, and we want to change it. And that's where you want to get your hands dirty and write a little bit of tilt shift. So here I have the original tilt shift shader, but they have updated it with using the Gaussian function so that it looks like the other blurs that are provided by Flutter, and at the same time I have here one simple condition to say that only do it at the first 20% of, or 20% of the top of the view, and everything else ignore it and just return the original color that was provided to you. So that now hopefully that these things link to each other, because I wouldn't be able to create this or come up with an idea to create this unless I have seen them all and know which ones are the ones to look at. So if I look at the gradial background example here again, this is showing the one with using Flutter. As you can see, a very nice cutout over there. And if we do it using the tilt shift one that we have created, you can see that it is smoothly fading out with the scene. It's still using the same Gaussian variables, probably a little bit different here and there, but it definitely looks way nicer, and it achieves the effects that we wanted to do to replicate the Apple one. So the Apple Store one, you can literally use this example and do it. The same for the gradient, the faded gradient one. They are all being useful if you use the tilt shift effect. So the last one is, I just want to thank George for giving me the challenge to do this, because I really had no idea that will be possible unless you ask me to do it. But for some reason, it went viral and have been watched just for the last week alone over 100,000 times. So that is like, in terms of developer numbers, that is a very large number that I was so happy to see. But I'm going to show it to you again here. Hopefully it's going to work out. But one question I have seen a lot, I have done the demo using Android and iOS, and people were asking me whether that's actually sending the data or not. Like that, I have been mentioning that it is the animation, but definitely it's not sending the data or anything else. Even sending the data, I wasn't so clever enough to do it in a way where it will be more automatic than it is. So the way I'm doing it here is literally using a timer, as you can see over there. I'm just like waiting for the time to arrive, and then I have a little haptic feedback on my phone. So when both of them hit at the same time, I'm going to push them together, and then they will show me the effect nicely between two devices. So that will be the effect. It will be also included with the code base. But if I can take a look at this one here, I have tried to, because it was very hard to understand, I tried to put all the values that are relevant to making it look more real to the one that is provided by iOS, because this is by no means something where I call like a 100% replica. That will take a little bit more time of looking at the effect many more times, because it's not open source thanks to Apple. We just have to go look at the values and try to come up with an idea of what that value will be. So here I have tried to abstract those values here, where you can change them and see which one works for you best. It's very uncommon to see comments in these shader toy events, so it was very hard to at least get an idea of what's happening here. But this is the part where the blur is happening. It's using a very simple one. It's not using a Gaussian one, but that's something where you can get some time and try to do it by yourself. This is the last demo. Now let's do a little bit of practicality speaking. The demos I have shown you using something new. I was introduced to Flutter just last year, called GPU images. So these GPU images are a snapshot of the image, or like whatever was rasterized by the previous frame is going to be synchronously available to you through something called GPU image. So whatever was in the previous scene is going to be available as an image that is going to be possible to pass to the shader as a texture. And if you ask whether that is too practical or not, this same method of using GPU images is being used already right now in the Flutter framework for the zoom transition. So if you have the latest Android version and you have the zoom transition, you will see that it doesn't animate everything in a nice way, or at least if you have what are they called, platform texture. So if you have a platform texture like a map or something coming from the native side, it will be very hard for anyone to animate that and make a screenshot of it in Flutter at least. So practically speaking, this is very useful if you don't have platform views inside your view, and also if you have a short-lived animation, such as the animation of name drop. It was very short-lived animation. We are not going to use that method for anything where users need to be interactive all the time and they need to feel the real-time feedback. The widget that Flutter team is using is called Snapshot widget. Not sure how many of you heard of the widget, Snapshot widget, or have used it? Yes, as I guessed, because I didn't either know it existed. I had to make my own version of it, but I had to learn about that just last week, which is a very nice widget where literally it's going to take a snapshot of your whatever is inside of your tree and provide it as an UI image where you can do all sorts of transitions or effects on it simply by using fragment shader or something else. So another one important practical bit is that image filter now has something called compose, where it's not just a blur, so you can even mix the blur that is provided by Flutter with something else. So we can dilate, which is a way of saying that we have pixels and we want to get them thicker. For example, you have a view where pixels like they are there is a very high contrast. You really don't want to apply the reason blur effect is very much not not performant is because it has to go, as I said, of the sample, like it has to go through them pixel by pixel and try to average out and get the value for them. So if you get less pixels or you get less noise, it will make it more performant. This is not the case here, but it will. That's just in general. The case here is that we can do different effects that are combined with the blur. It's not just the blur by itself anymore. We can compose it with other effects. Just some random tips. Don't overuse the effect because it will be causing you some memory issues if you are having to store a lot of images. As I said, a short-lived animation is the best use case for this so far because it will be garbage collected after a while, and you don't have to worry about that happening all the time. This happened to me a lot of time. Is that if there is an actual need for the blur is a very nice and beautiful thing to see, but if it doesn't add up anything to the view, I think we can go back to the design team and ask them to remove it. I have had cases where I actually ended up over-engineering the background. They had a really nice background that has a blur effect with noise and sound and everything, and they ended up doing it all by Flutter widgets, but it turns out that they can use just a simple static image and it looks perfect on all the views, so it's just something to remember. Cache whenever possible. I think the snapshot widget is the best example of that. If you have a view that is a static that's not going to be interactive all the time, just cache the value. And the last one is something called blur hash. If you have a backend where it can treat your images, take a look at the package called blur hash, where you can generate just a simple random a hash or a very, not very large, but very small string that you can use to display a very nice, smooth representation of the image based off its colors. But this has to be done in a way in the backend, so it will make it very easy to consume by the front-end applications. This is the overview. I hope I'm not going over my time, but I'm good. Okay, so this is the high overview of what's happening with the blur effect in Flutter, at least in Impeller, because that's the one we are using right now. Some of you might have noticed issues with the blur with Impeller. It's a bit different than the one in Skia. You will not, unless you have snapshot tests in your application, you will not have been triggered about that. But there are a lot of issues where the fidelity compared to Skia is not the same. But let's use the excuse of it's blurry, then it's blurry. Then why do we need to get to the same version? But the Flutter team have some work to do, and they have some items in progress in order to get them to look the same, even though that will cause them some performance drops that they will have to think about. But that's just the overview. These are the two ones that they have picked out for future improvement that they think should be considered subscribing to. One is allow defining an image filter, so that it will be very easy for us to do all of these effects with native image or with just native Flutter widgets without having to go through the whole process of trying to find a very nice blur that can have the effect at the top or the bottom. Like we can use like just a shader mask and do it, to apply the effect that we have seen initially, the Apple Store one. We will be just using the image filter on a shader mask or something like that. Scale down the Gaussian blur. This is something I think they are literally working on it as of right now, and it will make at least the current version of the Flutter blur a little bit faster just by doing two times going through the blur effect. So it's a very common way of getting the blur effect to perform better. So that's a summary of the talk. We have talked about all of these things, and I hope one of them got your attention. But last but not least, this is an LLM written thing, but directed by me. But the blur effect looks really cool in a way that is easy to appreciate. It might cost a bit more, but it's worth it when you see what's in store. You might spot the change, don't worry, that's not strange. Fine-tune here and there, experiment, arrange, and the perfection you will arrange. If your frame starts to stutter, if they jump or they don't flutter, optimize your layers, check your sigmas, ensure there is nothing in a clutter. Remember, with Flutter, possibilities are vast, creativity is never last, embrace the blur and you will have a blast. Thank you.